Click the bell icon to get latest videos from Ekeeda.
Hello friends, in this topic I'm going to talk about the structure of tetracyanoplatinum ion on basis of VBT. So now let us understand this topic very clearly. So friends, here I'm going to talk about the structure of tetracyanoplatinum ion, but for that we should understand the electronic configuration of platinum. But let us understand that is the platinum. Suppose if we are talking about, and platinum has an atomic number of 78, and suppose if we are concerned with the outermost shell. So the outermost shell, that is what we have that is I could write it over here as 5d9, then I could write that is 6s1, and then it would be 6p0, just for an instance. So in that case, suppose let us understand that is if the d orbital, that is if the d subshell consists of 9 electrons and the s orbital consists of only 1 electron, this is nothing but the outermost shell or the valence electronic configuration of the platinum. But we are talking about that is platinum which is present in the form of a complex. So that for the central metal atom, that is the platinum, which will have an oxidation number here. Suppose if we will calculate, so we'll get to know that is the platinum is having the oxidation number of 2+. So for that, or to obtain 2+ charge on it, obviously it has to lose 2 electrons. So in that case, 1 electron it will be lost from the cs orbital, and one of the electron it will be lost from that is d orbital, that is 5d orbital. So in that case, we could get that is 5d8, 6s0 and 6p0. And suppose if we are concerned with the orbital, so therefore we understand that is the d subshell, it will consist of that is 5 orbitals, that is 1, 2, 3, 4, and this is the 5th one. So talking about s orbitals, so s consists of only 1 orbital, while talking about p, it consists of 3 orbitals. That is what we know. So here there are 8 electrons, so in that case we have to fill the 8 electrons, and the 8 electrons will be filled according to the Hertz rule. So therefore in this case, this is 1, 2, 3, 4, 5, 6, 7, 8 electrons, and there is no electron in the s orbital and there is no electron in the p orbital. But here we can find that is there are 2 unpaired electrons, but the ligand, that is what it has been surrounding the central atom, that is platinum, this cyanide is in fact a strong field ligand, and whenever the cyanide is approaching or during the complex formation, what happens is the cyanide, since it is a very strong field ligand, so obviously there will be pairing of these electrons, and this kind of pairing of the electrons is known as spin pairing within the d orbitals, and that is what we could get the orbitals in this form, where we could find that is the 5 orbitals of the d, 1 orbital of s, and 3 orbitals of p. So in this case there will be pairing of these 2 electrons, and in that case we could get 1, 2, 3, 4, 5, 6, 7, 8 electrons, and in that case basically 4 are paired electrons. So therefore we have got the empty orbitals, and those empty orbitals are d, 1s and 3p orbitals. But we have to look out the number of ligands. So here we have that is 4 cyanoligands, and in that case we need 4 that is empty orbitals of the central metal ion. In that case it is platinum 2+. So therefore we have that is 1, 2, 3 and 4. So that means we have 1d, 1s and 2p orbitals. So in that case we could say that is the central metal ion, that is platinum 2+, it will undergo through a hybridization of that is dsp2, and in that case the structure, that is what we understand, it is square planar. So here basically we have understood that is the platinum, it will undergo through hybridization of dsp2, and this will give a geometry to the complex as a square planar geometry. So now let us draw the structure of those. So in that case the platinum, it will be in the middle, while it will be surrounded by the cyanoligands. So this is basically the cyanoligands that it will surround the central metal atom, and each cyano or each cyanide group, it will give a lone pair of electron to the central metal atom. So that's the case. If we could find that is this empty orbitals, it will get overlap with the ligand orbitals, and this is 1, 2, 3 and 4th ligand. So therefore the 4th ligand, that is of cyanide, so therefore they will get overlap, and the more the overlapping, so the more the extent of overlapping, the stronger it will be the bond strength, and this is what I want to discuss about. So Thank you friends for watching this video. I hope you have understood this video very clearly, and I hope I'll see you next time. Till then, don't forget to subscribe Ekeeda channel. Thank you so much.